Hello everyone. This is Geological Interpretation Map 4. So this is very interesting exercise, and you will learn something new from this exercise. Okay, and I will show you 3D also, 3D view also of this map. Okay, so that you can understand the things much. Okay, so if we look at this map, I'm able to see this lithology. Okay, like this shape, and I am again seeing this lithology here. Okay, and it means if I will walk from this side to this side, I will see that if this is my one number, this is two, this is three. Okay, suppose 1 2 3. Okay, then again I will get 2 and then 1, and then this side again I am getting 2. Okay, so there is a repetition of strata. So if there is a repetition of strata, it means either folding or faulting is there. So we have to identify that either it is a folding or a faulting. Okay, so how we can interpret that thing? If we know the dip of the strata, we can interpret from that. Okay, either it is a folding or a faulting. Okay, so now we are going to find out the dip. Okay, this is the boundary. Okay, the same boundary is cut by this contour, same contour twice. We mark that points. Okay, this is our 700 contour, this is our 700 contour. Okay, and if we look at this part, this is our 600 contour, this is our 600 contour. Okay, now we have to draw the parallel lines. This is our strike. Okay, so from higher to lower elevation the beds are dipping. Okay, so it means it is dipping this way. Okay, and we can calculate the dip also. Okay, if you want to go to more detail, so it is approximately near about 9.9. I am considering it a 1. Okay, for easy calculation. Okay, it is 1 centimeter. Okay, horizontal distance. Okay, elevation difference is 100 meter. Now I'm using this scale. This is 2.5 centimeter is equal to how much? 500 meter. So 1 centimeter is equal to 200 meter. Okay, so here our horizontal distance is 1 meter, so it means 1 centimeter, so it means it is 200. Suppose this is our alpha dip. Okay, so if we want to calculate the alpha, so tan alpha is equal to 100 by 200. Okay, so it is 0.5. Alpha is equal to tan inverse 0.5. so if you can calculate this. Okay, so in this way we can calculate the data. Okay, so either all the strata are dipping in this way. I know that this strata is dipping like this. Okay, if this is our north, this data is dipping toward east. Okay, if we look at this part, okay, I'm getting the same points. This is 500, this is 500, and this is 400, this is 400. If I'm drawing this, this one is our 500, this one is 400. From higher to lower elevation beds are dipping, okay, and the distance is same, okay, almost same, okay. So both the dips are dipping toward each other with the same angle, okay. Both the dips are dipping toward each other with the same angle. It is a what kind of it is a symmetrical fold, okay, till now, okay, but we are interpreting, okay, because both are dipping toward each other. Either it is incline or anticline. We will decide, we will go with, okay. Now if you look at this part, we are getting I measure this distance, it is also same, okay, and it is dipping toward this side, okay. So now the condition is like this. Condition is like this part is dipping toward this side, this part is dipping toward this side, and this part is dipping toward this side, okay. It is like this. It means this is syncline, okay, and this is our anticline part, okay. Till now the situation is like this, okay. Either it is a plunging fold or not. Now we are finding out that, okay. After I will make more picture, okay, clear picture, okay. Now either it is a plunging or not. If we look at this part, okay, we are getting the same contour cutting the strata at the setup boundary at a two place, and this one also, okay. So I'm going to draw this, okay, and the horizontal distance is 6.6, okay. So we can use this as 0.6 means 120 meter, okay. At 200 we have to write 120. In the same way we have to calculate the dip, and it is dipping toward this one is our 300 strike, and this one is our 200 contour line, okay. So it is dipping toward north, okay. So it means it is dipping toward north, okay. Now the scenario is like this. No, sorry, it is something like this, okay. So it means it is something like this. This side is dipping this way, this side is dipping this way, and the whole strata is dipping toward north, okay. So now these beds are dipping like this, and this strata is dipping like this, okay, and these beds are also dipping in the northern side, okay. So it is showing us as a plunging sin form, okay, because beds are dipping toward each other, okay. And in case of anticline, beds are dipping away from each other. This is a case, okay. If this is like this, it should be like this is a case, it should be like this, Okay, here it is like this. Okay, so how we interpret that? Okay, so now the situation is like this. We want to draw roughly now. These weights are dipping toward this way, and overall dipping this way, and these weights are dipping this way. And we look at this part. Okay, if we draw the strike line for these weights, so it will also telling us that this one is our 500. 5 save contour we have to select. Okay, okay, this one is our 500, this one is our 400, from higher to lower, the same. Okay, so this is the case. It's something like this. We look carefully now. We look carefully. This is the case. Okay, this side we are getting this pattern, and this side we are getting this pattern. Okay, now this one is our this is the case. These weights are dipping toward this side, overall weights are dipping toward this side, this limb of fold is dipping this way, and this limb of fold is dipping this way. So it is a plunging fold. Okay, but if we visualize our map, okay, it seems like this is the fold. Okay, this is the fold, and it is plunging like this. Okay, or plunging like this. Okay, if it is like this, okay, if we look at the map, it seems like that. Okay, but this is not the true. Okay, why this is not true? Okay, it seems like that it is a sin form, plunging sin form. Okay, why it is not true? Why it is a sin form, but plunging toward north instead of south. I will draw it later, but I want to explain you in a detail. Okay, why this is so? Suppose this part is at higher elevation. This contour is 600 contour. Okay, this contour is 600 contour. We are getting some rock at 600 contour. Then again we are getting while going. Okay, and we are getting the same rock at 300 contour. If weathering took place at this part, we are getting this as a circle. Okay, So how this is going to be happen if some rock is exposed at 600 meter height and we are getting the closer at 300. Okay, getting the closer at suppose now I'm plunging this fold now. Now I have to draw some horizontal lines now. These horizontal lines, these are the horizontal lines. These are the horizontal lines. Suppose this is our 300 contour. This is our 600 contour. But this is going to happen due to the weathering, okay? This shape we are getting now, this is due to weathering. I'm just drawing the horizontal, but this is the not the actual. I'm just saying that how we can get the same strata at lower elevation also. Okay, due to weathering we will get, okay? So now I'm going to draw the so it means this is I'm drawing this is our fold axis, and if I want to give the symbol to this, symbols is like this, and I will put a arrow toward this. It is plunging toward this side, and this symbol is representing syncline. Okay, and this part is our, this data is dipping toward this side, this data is dipping toward this side, and this one is our I can use the contour tool for drawing this, but right now I'm not doing that, okay? And now data is plotting like this, okay? And it is plunging toward, both are plunging toward north, okay? But it is inclined, we are putting a single symbol like this. But if it is anticline, putting a symbol like this, okay? Okay, this like this symbol with dipping away. Okay, this is a type of symbol, okay? So this is the fold axis or axial plane, okay? Fold axis is also like this. This is the axial plane, okay? Hope you understand. Okay, it is like this, and this part is, it is like this, and this part is like this. Okay, simple. So if I want to draw the cross section of this along some line, suppose this is our line that I already mentioned in the map. I'm going to draw cross section along this line roughly. So this is our contour 500. So I have to mark roughly 100, 200, 300, 400, 500. Okay. So this contour is our 500. Okay. And if we will start from this side, this contour is 600, then 500. Okay. This is our 600 contour. This is our 500 contour. This is our 400 contour. This is our 400 contour. This is our 500 contour. Okay, this way. And from this side it is falling between 700 and 600 contour. We will start with 650. Okay, so now I'm going, and this side it is falling between 400 and 500, so 450 we will go. So this is a topographic, okay, expression along XY line. Okay, so now I have to plot the setup. But okay, this point is falling on this point. This point is here. This point is here. This point is getting this point at here. Okay, this part are dipping. This side is dipping toward this side. We can find out the dip. Okay. The same way, this part is dipping toward this side, and this data is dipping toward this side. Okay, the same dip amount. Okay, so if I want to construct this, okay, this is our incline, this is our anticline, and this is our north, this is almost our northwest, southeast. Okay, these are the lines that we are seeing. Okay, full stretch lines. Okay, and these are the dotted lines. This and this side again we are getting. Okay, and these are the dotted parts. In this way we are drawing. Okay, now the oldest one is this part is the oldest one, because anticline core part is the oldest one, so it means our oldest one is 1. I will draw 1 2 3 oldest. Okay, and this is, and this part is, okay, this part is plunging. This incline is plunging toward north, and anticline is also plunging toward north. Okay, and okay, symmetrical, and all the limbs have equal amount of dip, so we can say that symmetrical, northerly, plunging, syncline, and anticline fold.